The most important people on Wikipedia, in some very specific way, are tennis players and professional wrestlers. Hi there, I'm Y, and this is one of those I found something weird about Wikipedia videos. And I might be the first one ever to find out this particular thing. It's nice to bring some new knowledge to the world, even if it's a useless fact about tennis players and pro wrestlers. But let's start from the end. If you enjoyed this video— wait, no, that's silly. Let's start from the beginning. A few years ago, for a university project, I tackled the question, who are the most important people on Wikipedia? In other words, of all the people who have a Wikipedia article, who are the most important in terms of their article? That wasn't the whole project, but it's the part that matters right now. And for this video, I actually redid it, using the latest Wikipedia data. But what does most important in terms of their article even mean? That's up to you. Maybe you could check which articles are the longest, or which ones have the most translations. But for my project, I looked at the structure of Wikipedia, the links that lead from one article to another. And when you keep track of links between things, you get what mathematicians call a graph. A graph is a set of things, called nodes, with connections between them, called edges. How you draw the nodes doesn't matter. It's only about what they are and how they're connected. And they can stand for anything. Maybe the nodes are people and the edges mean is friends with. Or maybe the nodes are countries and the edges mean has a border with. And you can also think of Wikipedia as a graph. The nodes are the articles and the edges are the links that lead to other articles. If article A links to article B, those two nodes have an edge. This is what's called a directed graph, which means the edges have a direction to them. They don't have to go both ways. And so, for my project, I built a Wikipedia graph, but not a full one. I was only looking at the English Wikipedia. Other languages have their own completely separate graphs. And I was only looking at articles about people. Still, there are over 2 million nodes in this graph, 2 million people on Wikipedia, and almost 9 million links between them. I really wanted to show you the whole thing, but my computer didn't. So here's just the people whose names start with a K. Treating something as a graph is a really simple idea, but it lets you do all kinds of interesting math. You could ask, what graphs can I draw without lifting the pen? Or how do I find the shortest path between two nodes? And for my project, I was asking, who are the most important people in the Wikipedia graph? In math, it's usually called centrality. So, what are the most central nodes? There's not one perfect way to define what central means. There are many different kinds of centrality. And for my project, I tried 3 of them. Spoiler alert, one of them is gonna lead us to tennis players and pro wrestlers. Centrality number 1, degree. You could say a node is central to a graph if it has a lot of edges connecting to it. That makes sense, right? A node with 10 edges feels more important than a node with just 1. That number is called the degree of the node. And the Wikipedia graph is a directed graph, so you can also count the in degree, that's how many other people link to this person, and the out degree, that's how many other people this person links to. But for my project, I combined the two and just looked at the degree. I had the whole graph as a text file, where each line is a link between two people. So I just had to go through it line by line, and anytime a person appears, either with a link to them or a link from them, count their degree up by 1. At the end, I had a list of the most important people on Wikipedia. If by important you mean having the highest degree in the graph. And yeah, I guess that works. It's kind of centered around American presidents, but that's not too surprising. They are extensively covered by Wikipedia. And even a little further down the list, we get people who are pretty well known. Now that was a pretty straightforward way to find out how central a node is. What are some other ways? Centrality number 2, PageRank. This is specifically for directed graphs, and it's actually similar to degree, just a little more fancy. You could say a node is central to a graph if it has a lot of edges going to it, but only if those edges come from nodes that are also very central. It sounds like circular logic, but it works out. To calculate these PageRank scores, you simulate a walk along the graph, visiting nodes and following the edges at random. To make sure all the nodes can be reached, every so often, maybe 10% of the time, you teleport to a random one. And the more often you visit a node, the higher its PageRank score. A node is rewarded for having lots of incoming edges, but only if they come from other high-ranking nodes. If they're from nodes that you rarely ever get to, they won't matter much. PageRank is great at ranking web pages by importance. After all, you can think of the web as a directed graph, where the nodes are pages and the edges are links between them. It's what made Google so successful in its early days. They used PageRank to get you the most relevant search results. And just like Google used it to find the most important pages on the web, I used it to find the most important people on Wikipedia. It's almost the same thing, except instead of web pages you have web pages, and instead of links well, no, it's literally the same thing. Side note, instead of doing a random walk, you can calculate the PageRank scores more directly. You need a table, a matrix, with all the probabilities of going from one node to another, and a list of numbers, a vector, that represents which node you're on. Then, doing one step in the random walk is the same as multiplying the vector and the matrix. You get a new vector where the distribution is a little closer to the final scores. To get the final scores directly, you can solve this equation for a vector that doesn't change anymore when you do a step. Or well, a computer can. For my project, I tried to do it the matrix way, but the Wikipedia graph would need a matrix with 2 million rows and 2 million columns, and my computer wasn't too happy about that. So I just did the random walk for as long as I could, until every node was visited at least 100 times. At the end, I had a list of the most important people on Wikipedia, if by important you mean having the highest PageRank score. And they are presidents again, just shuffled around a bit. But again, that feels reasonable, and all the other top spots are definitely well-known people. So will the list just always be dominated by American presidents? Let's try another way to measure it. Centrality number 3, k-Coreness. You could say a node is central to a graph if it's part of the graph's core, or to be exact, the k-core with a high value of k. So what is a k-core? If I say it's the maximal connected subgraph where all the nodes have degree at least k, and that's enough for you, that's great. Otherwise, imagine trimming the graph, removing nodes with a low degree and keeping only those with a high degree. And imagine multiple rounds of that. In round number 0, you remove all the nodes with degree 0, all the nodes with no edges. What remains is called the 1 core, because all the nodes in it have at least one edge. In round number 1, you remove all the nodes with degree 1. And here's the thing, you repeat that until there are no more nodes with degree 1 left. A node may start out with degree 2, but by removing other nodes, it can end up with degree 1, so it needs to go as well. There's a kind of snowball effect that affects more nodes than it first seems like, and that's what makes the k-Coreness different from just counting the degree. After round number 1, what remains is called the 2 core, where everything has a degree of at least 2. Then, in round number 2, you remove all the nodes with degree 2, and what remains is called the 3 core. And so on. The coreness of a node is the innermost core that it's a part of. If it's part of the 1 core, the 2 core and the 3 core, but not the 4 core, it gets a coreness of 3. You could also say it's the round where it got eliminated. If it survives up to round number k, it has coreness k. And the higher the coreness, the more central the node. When it survives all the elimination rounds, it's part of the inner circle. For my project, I decided to write all the k-Coreness code from scratch as well. And assuming I coded it right, at the end, I had a list of the most important people on Wikipedia. If by important you mean having the highest k-Coreness. And with a k-Coreness of 39, the most important person on Wikipedia is... Who? I mean, I'm sure a lot of people know who this is, but for the actual most important person on Wikipedia, I would have expected someone we all know. Well, okay, the first place is actually a 101-way tie, because everyone in that core has the same coreness. So maybe the rest is more what I'd expect? I need to find out more about these people. I wonder if they have a Wikipedia oh right. It turns out, as you've probably guessed, that the people with the highest coreness are all tennis players and professional wrestlers. The very top is all tennis players, but pro wrestlers are following close behind. And those are very clearly in a league of their own. Of the first 24 cores, that's the first 6,000 people, the vast majority are either tennis players or pro wrestlers. It's only at the 15 core that the structure goes back to normal. All the people you think of as well known or important, movie stars, musicians, writers, politicians, scientists, they don't stand a chance against tennis players and professional wrestlers. So, why? What makes tennis and wrestling so central to Wikipedia? Now, I don't know much about tennis or professional wrestling, but what I do know is they're both single-person sports, where a person has a 1v1 match against another, and those matches are all worth documenting. For our top-ranking tennis players, their Wikipedia articles are full of other people they've played against. Defeated this person, lost to this person, then defeated this person, and so on. Same for the pro wrestlers. Won against this person, lost to this person, teamed up with these people, apparently had a feud with these people, and so on. In short, tennis players link to a lot of other tennis players, and pro wrestlers link to a lot of other pro wrestlers. This is a big difference to many other sports, like football or football. The Wikipedia article of a football player might mention the teams they've played for, but not every other player they've ever passed the ball to. Of course, it's always true to some extent that people link to other people in the same field, but apparently it's never as systematic as it is with tennis and wrestling. So why does linking to each other lead to a high K-Coreness? Well, if someone has K-Coreness 39, that doesn't just mean they have 39 links to them, it means they survived 39 rounds of elimination, and all those links come from people who also survived 39 rounds. If you go by in degree, someone with a lot of links ranks very high, even if they come from less connected people. But when you calculate the K-core, those people are eliminated very early on, and then there's no one left to help them survive the next round. The best way to survive is to link to each other. If you have a group of 10 people who are all connected, they all have degree 9. So they're guaranteed to survive the first 9 rounds and get a K-Coreness of 9. And as far as I can tell, that's what's going on with all the tennis players and pro wrestlers. Because of how their sports are played, their articles mention a lot of their colleagues, and those connections protect them from being removed from the graph. Simply put, tennis players and professional wrestlers have got each other's backs. So what's the moral of the story? Maybe it's that k-Coreness is not the right way to find important people on Wikipedia. Or maybe we just shouldn't call it important and instead say that k-Coreness finds the most tightly knit groups. Or maybe tennis players and pro wrestlers really are the VIPs of Wikipedia. Why not? I know at least 6,000 people who would agree. Either way, thank you so much for watching. If you enjoyed this video— wait, no, that's silly. Let's start from the beginning.